Okay, so in this video, we will look at the quotient rule, and that is how to differentiate a quotient of two functions. So how do we find the derivative of f of x over g of x? And the quotient rule shares part of almost the product rule. So what you'll have will be the derivative of f over g, sorry, the derivative of f over g will be the derivative of f, so f prime of x, times g. So the derivative of the numerator times the denominator, and then minus the numerator, f, times the derivative of the denominator, g. So f prime times g minus f times g prime all over g of x all squared. And that is the quotient rule. And if you look, it's actually quite simple. All you need is the derivative of f of x, the derivative of g of x, and then you plug them in the formula, right? Here's f prime, here's g prime. You already know g, you already know f, and you already know g, so you can just square it. So find the derivative of the top and the bottom of your fraction, plug them in, and then do a bit of algebra to simplify, and you have the derivative of a quotient of two functions. Let's look at a few examples. If we look at the derivative of, say, 2x plus 3 over, let's go with 4x minus 7, say, then we can apply the quotient rule. We have a quotient. So the quotient rule says the first term is the derivative of the numerator. The derivative of 2x plus 3 is simply 2 times the bottom of your fraction, 4x minus 7, minus the numerator, 2x plus 3, and here be careful to use brackets because it's the negative of all of f of x, so the negative of all of 2x plus 3, times now the derivative of the bottom. The derivative of 4x minus 7 is just 4. And this is all over g of x all squared. So 4x minus 7 all squared. So if you look here on the numerator, we have a difference of two terms. Before multiplying out this by 2 and this by 4, we can factor. It's not much, but we can factor a 2. So let's do so. We'll have 2 times. We factor 2 from this one. We're left with 4x minus 7. Minus, factor 2 from 4, and you're left with a 2. So minus 2 times 2x plus 3. All over the square of 4x minus 7. And now we can multiply out and regroup similar powers of x in the constant terms. And let's see what we're left with. We have a 2 times 4x minus 7. Negative 2 times 2x is negative 4x. Negative 2 times positive 3 is negative 6. All over 4x minus 7 squared. And if you notice, we have 4x minus 4x. This cancels. And we're left with negative 7, negative 6. That's negative 13. Negative 13 times 2, negative 26. So negative 26 all over 4x minus 7 squared. And there you have it. The derivative of 2x plus 3 over 4x minus 7 is just negative 26 over 4x minus 7 squared. And you see it's much faster with the quotient rule finding the derivative of a quotient than it would have been with the limit. Let's do one more example where we have on the top not just lines, but additional powers of x. So what if we had the derivative of, let's go with 3x squared minus 1 over x cubed plus 4. So let's apply now the quotient rule one more time. The derivative of the numerator, this is 3 times the derivative of x squared, which is 2x. 3 times 2 is 6, so we get 6 times x, minus the derivative of 1, which is 0, so we just get 6x. The derivative on top is 6x times the bottom, x cubed plus 4. Minus, and now we flip the role of the derivative, so minus the top, minus 3x squared minus 1, times the derivative of the bottom. Well, the derivative of x cubed is 3x squared, plus the derivative of 4, which is 0, so all we have is 3x squared, all over x cubed plus 4, all squared. And now again, we're done with the derivative. That's it. The derivative of this function is this function. The rest is just trying to simplify the expression as much as we can. Before multiplying things out, let's look for common factors. Well, there's a factor here of x, and a factor here of x. We can pull 1 out. So we factor this 1 out. We have 2 x's here, x squared. If we take away 1, we're left with 1. There's also a factor of 3. Let's factor 3. So the 3 is gone. And if you factor 3 from 6, you're left with 2. And now if you look, we have 2 times this cubic minus this quadratic times x. No more common factors. Let's see what we're left with. 2 times x cubed plus 4 will give you 2x cubed plus 8 minus 3x squared minus 1 times the leftover x. Well, x times 3x squared is 3x cubed minus that, so minus 3x cubed. X times negative 1 is negative x. Negative of that, positive x. And that's our numerator. Of course, all over x cubed plus 4 squared. And now all that's left is to regroup similar powers of x. We can write x times 3 as just 3x, so that's 3x, times, well, we have 2 cubic terms, 2x cubed minus 3x cubed, that's a negative x cubed. There's a single factor of x, so plus x, and a single constant term, plus 8, over x cubed plus 4, all squared. And there you have it. The derivative of this function simplified is this function. And if you would find the derivative of this function from the definition using the limit as h approaches 0, because of the quadratic term and the cubic term, it would have been a lot of work. And if you look here with our rule of differentiation, the quotient rule, not using limit, but the quotient rule instead, it took us 3 lines. So it's much easier. And that's the quotient rule. In our next video, we will be looking at the chain rule. This will be the fancier rule of differentiation. It's a bit more complicated, and it's our last one.